Animating a newly designed 3D character from motion capture data when the skeletal structure is given is a challenging task. The classic process of rigging and skinning the character with the mocap skeletal structure, followed by deformation in the joint regions, requires a tailored, pose-specific refinement. We present a framework that makes the mocap to deformation process simple. Our method can rig and skin new characters with a specified skeletal structure, and generate neural blend shapes, a set of residual and pose-dependent displacements. The blend shapes refinement results in high-quality deformations, which are especially important in the joint regions. Existing techniques do not provide control over the skeletal hierarchy, and do not incorporate the corrective pose-dependent shapes, resulting in undesirable deformation artifacts. Our architecture is inspired by the typical animation workflow and contains two main branches: an envelope deformation branch that learns to rig and skin the character with the mocap skeletal structure, and a residual deformation branch that learns a set of pose-dependent residual displacements. Our network is trained on articulated shapes with the same articulation structure and learns via indirect supervision. During training, the network observes deformed shapes and learns to infer a set of skinning and rigging parameters that conform with the target skeletal structure, as well as a joint-dependent blend shape deformation, thus bypassing the need to provide a consistent ground truth for the rigging, skinning, or blend shapes parameters. For more details, please refer to the paper. Our results demonstrate that our framework can successfully extract rigging and skinning for different characters that were not seen during training, and predicts pose-dependent deformations. Observe that our envelope deformation outperforms baseline LBS techniques, since it was trained on data with high-quality deformations. Also, our neural blend shapes further refine the quality of the deformation in a pose-dependent manner. With a single forward pass, we can even modify the skeletal structure of existing animations and improve their deformation quality. Our framework is also robust to variations of mesh connectivity and accurate in estimating deformations with stability. We compare our method to RigNet, which outputs an arbitrary skeletal structure, so it's not directly possible to animate the output skeleton with mocap data. Here we compare our results to Blender's automatic skinning functionality. Our fully automatic approach outperforms Blender's deformation quality. We asked an animator to manually correct the automatic deformation produced by Blender. It took them a decent amount of time to reach a comparable deformation quality, which our network achieves with a feed-forward pass. Here we visualize the activation of the blend shape coefficients as a function of pose. Despite not being supervised directly, the network infers an accurate relationship between the two. Here, the network was trained with no connectivity augmentation and no garment augmentation. It can be seen that the network struggles to generalize the skinning weights to unseen characters. Thank you for your attention.